Type of chemical reactions. Okay. Today you're going to learn about different type of chemical reactions. See why different type of chemical reactions? Because based on what you have in the reactant, later you have to be able to predict the products. Okay. Using the type of chemical reactions that, by the way, is not a new topic. If you were in my physical science class, we went over this. Okay. So like identifying the type of chemical reaction is not important in chemistry, but you're going to be using this topic just to predict products based on the type of chemical reaction. Okay, that's the goal of today's lesson. Using the different type of chemical reactions, you're going to be able to predict products. First type of chemical reaction that we have over there. The first type, synthesis. And what is a synthesis chemical reaction? It's a reaction in which two elements or two compounds, they are gonna combine to create only one product. I'm gonna repeat that one more time. A reaction in which two elements or two compounds, they're gonna combine to create one product. One product. Example of synthesis reaction. When you have a metal reacting with another metal, producing an ionic compound, synthesis reaction. When you have a non-metal combined with another non-metal to produce a covalent compound, you have a synthesis reaction. Now, see, element, compound, element, compound. But you can have compound and compound just to form another compound. And since you have only one product, the reaction is going to be classified as a synthesis reaction. So when you have a metal oxide, and when I'm talking about metal oxide, sodium oxide, lithium oxide, manganese oxide, iron 2 oxide, magnesium oxide, barium oxide, plus water, you have a synthesis chemical reaction, and then a hydroxide is going to be formed. Miramos hydroxide is a polyatomic ion. What's going to happen with the metal? See, it's a hydroxide made by the metal that was present here in the oxide. Okay, so if you have an example over here. Let me see, because you have an example. If you have lithium oxide combined with water, are you going to have over here sodium hydroxide? Impossible, because you didn't have sodium in the reactant. So when you have a metal oxide reacting with water, they're going to be producing a hydroxide created by the metal that was in the oxide that you have in your reactant. Questions about that? No? And there's another example of synthesis reaction. When you have a metal oxide, calcium oxide, barium oxide, magnesium oxide, lithium, aluminum oxide, reacting with carbon dioxide, carbonate is going to be formed. A carbonate. In the carbonate, you have the metal plus the polyatomic ion carbonate. Miramos, where is the metal is coming from? From the metal that you have in the oxide. Questions about that? So you have here examples. Metal, non-metal, ionic compound. Non-metal, covalent compound. Metal oxide plus water, hydroxide. Metal oxide plus carbonate plus carbon dioxide, they're going to be forming the carbonate with the metal that you have in the oxide. Like here, the hydroxide with the metal that you have in the oxide. Questions about that? No questions. The composition chemical reactions. What are the composition chemical reactions? They are the opposite of the synthesis. Opposite of synthesis. Here, instead of having one product, you're going to have one reactant. Only one reactant. It's the opposite of synthesis. So you have an ionic compound The ionic compound is going to be decomposing into the metal and the non-metal. If you have a covalent compound and it's decomposing, it's going to be decomposing into the non-metal and the non-metal. See? The hydroxide, let's say that you have, I don't know, aluminum hydroxide decomposing, is going to decompose into the metal oxide, aluminum oxide, plus water. Or if you have a carbonate, aluminum carbonate, is going to decompose into the metal oxide and carbon dioxide. Aluminum carbonate will decompose in aluminum oxide plus carbon dioxide. Questions about that? No? And you have examples over here. See? You have an ionic compound, you have aluminum oxide that is going to be decomposing into the metal, which is aluminum, and the oxygen. Can you balance that equation? Pretty easy. Then you have over here sulfur trioxide decomposing into sulfur, okay, by the way, you don't have to know that, and oxygen. See that? Into the non-metal and another non-metal. Then you have the hydroxide decomposing into the oxide plus water, and the carbonate, in this case potassium carbonate, that is going to decompose into potassium oxide plus carbon dioxide. Okay, questions? You don't have any questions? Combustion. Okay, just a clarification. Some of the synthesis reactions that we were discussing, some of them, they can be classified as combustion reaction, but you don't have to worry about that because I'm going to be very specific on the test. Are you listening to me? Can you listen? Am I on mute? No? Am I? No? Okay. Okay. So combustion reactions. In a combustion reaction, always you're going to be burning organic material. Miramo, we don't know what organic material is. Any covalent compound made of carbon, hydrogen, or oxygen is an organic material. You have a combustion reaction when you have any organic material burning in the presence of oxygen. Okay? Questions about that? Now, combustion reaction, they are all exothermic, meaning that they are releasing a lot of heat. Questions? What is going to happen in a combustion chemical reaction? That depends. Or what is going to be produced in a combustion chemical reaction? Depends. Because you have two types. If you have a complete combustion, then you're going to have carbon dioxide and water at the end as the products. But if you have one that is incomplete, in addition to the carbon dioxide and the water, then you're going to have carbon too. And just think about the time that I was burning paper here in the class. Okay, by the way, you were in my physical science class and you were burning for the lab about physical and chemical exchange. You were burning a piece of paper. What happened over there? See, you have like a smoke. You know why? Because since the combustion reactions, they are exothermic, the water is released in the form of water vapor. And you know that carbon dioxide is also a gas. So you were observing like a smoke in there, so carbon dioxide together with water in form of the water vapor. But then you have the ashes in your dish. I remember that. In that dark, black ashes that you have in there, carbon atoms. So you have a complete combustion, you're not going to be able to see anything. Yeah, remember the last school year, I was burning alcohol, which is an organic material, here in the class, and there was nothing left in the evaporation dish. Nothing, because it was complete. Okay? When it's incomplete, you're going to have traces there of the carbon atoms. Okay? If you have here the example, complete combustion, then you have carbon dioxide and water, but when you have an incomplete, in addition to the carbon dioxide and water, you have carbon too. Can you balance that equation? Pretty easy. Until now, Ms. Ramos, super easy. Everything that you have said. Synthesis reaction, we have a metal and no metal, we have an ionic compound. The composition, then we have the ionic compound that are going to decompose into the metal and the no metal. Super easy. The combustion, we have the complete and the incomplete. Piece okay. Piece okay. Okay, now, this is when the problem is coming. Replacement reactions. We have two types. Single replacement, and then we have the double replacement. How can you differentiate that? If I'm telling you that iron is reacting with hydrochloric acid, do you have to compound? Iron reacting with hydrochloric acid. You don't have a double replacement. Iron reacting with hydrochloric acid. See, you don't have to compound. Do you have over there organic material burning in the presence of oxygen? You don't have that there. Okay. Do you have a hydroxide? Do you have a carbonate? Iron reacting with hydrochloric acid. You have an element reacting with a compound. So the moment that I'm giving you the reactants, you're going to be able to identify. It's a single replacement reaction, okay? And in the reactant, you're going to have an element and a compound. Copper sulfate, copper 2 sulfate reacting with iron. Do you have to compound? Do you have organic material reacting with oxygen? Do you have over there a carbonate? Do you have a hydroxide? That's the question that you're going to ask yourself. Okay? No. Copper 2 sulfate reacting with iron. You have an element, which is iron, and then you have a compound. Okay? That's how you're going to identify that you have a single replacement. And in the double replacement, you're going to have a compound and a compound. Sulfuric acid reacting with sodium hydroxide. Sulfuric acid reacting with sodium hydroxide. See? You have two compounds in there. No, it's not the, okay, a ver, let me see. Single replacement. Single replacement. You know that in a single replacement, you have a compound and an element, and I make a mistake over here because you have reactants here. Let me write that, reactants. And at the end, you're going to have the same. You're going to have a compound and an element, because the element in a single replacement, the element that was reacting there with the compound is gonna displace another element in the compound, and then you're gonna have a new compound plus the element that was replaced. Questions about that? No? Okay. Examples of single replacement reaction. When an acid is reacting with a metal, what's going to happen? An ionic compound is going to be formed, releasing hydrogen. And you're familiar with that chemical reaction because I was showing you that when I was explaining balancing. I was showing you the iron together with the hydrochloric acid, and you were able to observe the bubbles in there. What was formed in that chemical reaction? An ionic compound. What was the gas that was released? Hydrogen. Now you know that. You know that if iron, copper, any zinc is reacting with, sulfuric acid, the bubbles that you see in there, hydrogen. What is the ionic compound that is going to be formed? That depends on the acid that you have and the metal that you have. For example, and you're familiar with this one, with hydrochloric acid is reacting with iron, an ionic compound is going to be formed, see, metal, no metal, while hydrogen has been released. Now, when you look at this acid over here, this is an acid made of a monoatomic ion. So your ionic compound is going to be made of a monoatomic ion. Over here, this is another example. Sulfuric acid reacting with zinc. Okay, what's gonna happen? You're gonna have an ionic compound. And how that ionic compound is gonna be made? Zinc with a polyatomic ion, while hydrogen has been released. As I was explaining during class, when you have a single replacement reaction, always you're going to have in the reactants a compound and an element. A compound and the element. Okay, I was saying before that when you have a metal reacting with an acid, the product that is going to be formed is an ionic compound. What ionic compound? That depends on the acid, and that depends on the metal that was involved. For example, in this case, you're going to have an ionic compound made of a monoatomic ion, because when you look at the acid was made of a monoatomic ion. Now, on the second case that you have over here, you're going to have an ionic compound made of the metal and a polyatomic ion. Why? Because the acid that was in this example was made of a polyatomic ion. Okay, that's the most, how can I say that? Common example of single replacement that you will see in real life. Now, what is another example of single replacement? When you have a compound, but a compound that is not an acid, compound that is an ionic compound, and a metal. Now, what happens when you have reactions like this? That sometimes a reaction is not going to take place. When the reaction is not going to take place, when the metal that you have by itself is not able to displace the metal that you have in your ionic compound. Ms. Ramos, is how I'm going to be able to know that. How I'm going to be able to know that the metal that I have here in my reactant is not able to displace the one. See, look over here. It's not going to be able to displace the one that I have in my ionic compound. How I'm going to know that? So in order, okay, let me put that over here in the center. In order to determine what, okay, metal is gonna display one metal, you have to look at the activity series. And as you can see over here, all representative, I'm saying that one more time, representative metals, they're gonna be able to displace transition metals. So meaning that lithium, rubidium, potassium, calcium, sodium, they're going to be replacing the transition metal. Now, let's say that you have in your equations, lithium reacting, okay, with, let me see, phosphate, rubidium phosphate. Are you going to be able to see over here a reaction? No. Why not? Because when you look at the activity series, lithium is more active. Bueno, I'm wrong. Okay? Yes, you're going to be able to see that. Because when you look over here at the activity series, lithium is more active than rubidium. So lithium is going to be able to displace rubidium in there. What is the new compound that is going to be formed? Lithium phosphate. You don't need this, because they are in group 1, lithium phosphate, and rubidium is going to be displaced there. Okay? Now, let's say that you have this copper reacting with calcium carbonate. So you have an element and a compound. Element and compound. This over here is an ionic compound. Copper, which is a transition metal, is going to be able to replace calcium in that reaction. The answer is no. So in this case, you're not going to have any reaction, because remember, representative metals, they're going to be able to displace any transition metals. But within the representative, they have an order. And within over here, the transition, they have an order in there. For example, if you have, I don't know, let me see, zinc reacting with gold, platinum, silver, nitrate, you're going to have a reaction. See, the zinc is going to be able to replace the silver in there. But if you have, on the other hand, you have silver reacting with zinc nitrate, over here you're not going to have any reaction, because silver, as you're going to look over here in the activity series, silver is less active than zinc, so it's not going to be able to replace that in there. The same happens with the halogens. Halogens. Let's say that you have, okay, let me see. Sodium iodine. What's gonna happen in that case? That the chlorine, look at the chlorine, is more active than the iodine. So it's gonna replace NaCl plus iodine is gonna be displaced or replaced in that single displacement reaction. Same. So you're gonna use this over here. If the halogen or the metal that you have by itself is less active than the one that you have in your compound, no reaction is gonna take place. Okay, what happened with the double displacement reaction that you don't have to worry about the activity series, okay? So when you have two compounds and two compounds, they're reactants, okay, you're gonna have, okay, two new compounds at the end, and you don't have to look at whatever, you don't have to look at whatever activity series you have in there, because think about that. If you have two compounds and one of the metal, let's say that you have two ionic compounds and one of the metal is more active than the other, okay, you know always is going to be more active, one of them is going to be more active, then the reaction is going to take place. That makes sense, okay? So you don't have to worry about the activity series, but you have to take into account that in the double displacement reaction, always, okay, or most of the time, you're going to have a precipitate, the formation of water, or the release of a gas. We are not going to work with this one. With the release of a gas, we are not going to work with that one, but we are going to address the ones that are creating water, and then the ones that are creating a precipitate. Okay, water. What are the double displacement reactions that are creating water? That are forming. See, as part of the displacement that are forming water in there, in the products. Acid plus bases. You know that an acid is made of hydrogen, and a nonmetal. Let's say that you have hydrochloric acid in a aqueous medium reacting with sodium hydroxide in an aqueous medium. They're gonna switch the ions, negative and positive one, they're gonna switch. Sodium is gonna combine with chlorine in an aqueous medium because this one is soluble in water, and then water is going to form. If we call this in chemistry a neutralization reaction, because you have an acid over here reacting with a base, and most of the time the pH that you have at the end is a neutral one. We call that a neutralization reaction, okay? In this case, the acid that you have over there is made of a monoatomic ion. What's gonna happen, Ms. Ramos, if I have PO4? If I have, okay, an acid that is made of a polyatomic ion. Because over here, Ms. Ramos, you have an acid made of a monatomic ion. So you're going to have an ionic compound made of a monatomic ion plus the water. But in the second case that you are representing here, you have an acid, by the way, this is phosphoric acid, made of a polyatomic ion. How are you going to write the ionic compound? It's so easy. Aluminum is going to combine with, and you don't have anything here on the subscript because PO4 -3 phosphate polyatomic ion, the oxidation number is -3, and aluminum is +3, but you already know that, plus water in here. That's another example of a double displacement reaction in which water was formed as part of the product. Miramos an example in which the product is a solid. I was showing you one. It's copper 2 sulfate, aqueous, because I have a solution. Remember that blue solution was reacting with sodium hydroxide, another aqueous substance, because there was like the sodium hydroxide was dissolved, and you were able to see that blue solid forming in there. If that blue solid was caused by the formation of copper 2 oxide which was solid, plus the sodium sulfate that was dissolved there in the water that was involved in the aqueous medium. Okay, so 2 examples for double replacement. You don't have to look at the activity rule, at the activity series, because the reaction is going to take place anyway. Because when you analyze when you have two ionic compounds, one of the metal always is going to be more active than the other one, so the reaction always is going to take place. How are you going to predict the product? You're going to like switch. Okay, remember, in an ionic compound, this one over here, the metal is the positive one, the other part is the negative one. Metal positive one, the other one polyatomic ion, and then you switch positive with the negative, positive with the negative. That's how you find the products. In the case that you have an acid and a base, always same thing. Okay, this one in this case is positive with the negative, positive negative, positive with negative, and then you have the formation of water there as part of the product in a neutralization. A neutralization chemical reaction, which is an example of displacement.